Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome again to the TV learning programs. This is Teacher Pasco, and today I will be with Senior 5 chemistry students. But of course, even Senior 6 students, you can follow the lesson because I'm very sure you have covered this in Senior 5. So today we are going to have an assessment for unit number 6, the carbonyl compounds, because we have studied a lot. So this is the right time for you to check your level of understanding if we have really understood what we have been discussing in this unit. Without delaying, let's go to question number 1. Here we have the equations to be completed. And you will do it with me. We have propanol treated with lithium aluminum hydride in the presence of ether. What do we produce? You have some seconds to think about it, and then I show you the right answer. What type of reagent is this one? Lithium aluminum hydride. In which kind of reaction do we use this reagent? Hope you remember well. We use it in reduction, and when we reduce a ketone, this is a ketone, what do we get? We get a secondary alcohol. So the product here will be, we have CH3CO, CH3 treated with lithium aluminum hydride in the presence of ether. It is a reduction. We produce a secondary alcohol. This is the product we get. And for equation number 2, what do we have? We have, do you remember how we call this compound? It is ethanol. And ethanol, when it is treated with acidified potassium dichromate, what do we get? Treated with acidified potassium dichromate, this mixture. Remember, this is an oxidizing agent. What do we produce when we oxidize aldehydes? When aldehydes are oxidized, we always produce carboxylic acids. So the compound we produce here is CH3COOH. That is the product to be written on the right side of our equation. And here we have methanol. This is methanol reacting with a Grignard reagent in the presence of water. What do we produce? Do you remember what is the product? We know that Grignard reagents can react with aldehydes. They can react with ketones. And we know that when they react with aldehydes, we always produce secondary alcohol. When they react with ketones, we produce tertiary alcohols. But when they react with methanol, this compound, we always produce primary alcohols. So the compound we produce is CH3CH2OH. That is the product we get. CH3. The CH3 I have here is from the Grignard reagent, and this part is from the aldehyde. This is the aldehyde methanol, and this H is from water. And this gives us another product, which is ClMgOH. And this part is from the Grignard reagent, and this one is from water. Good. We go to the last equation to be completed. Here we have a condensation reaction. An aldehyde reacting with hydrogen. Do you remember what we get when we are conducting a condensation reaction? First of all, what is a condensation reaction, if you remember? We have seen that a condensation reaction, it is when we have an addition, but which is immediately followed by an elimination. So with the addition and elimination, if you remember how we did it like this. We have CH3, CH2. I will write it to help you remember what happens. And we add H2N, NH2, and I remember it very well. We did it like this. And we eliminate a water molecule to get this product, CH3, CH2, CH, N, and NH2 plus H2O. Okay? So the double bond which is here will combine. Let me write it well here, because we don't have one hydrogen. So it's better if we write it like this. Hydrogen, and then the two hydrogen atoms will combine with the oxygen, while the nitrogen will combine with the carbon to give us a double bond. Okay? So that is one of the types of exercises we can have in this organic chemistry, the unit of carbonyl compounds, completing equations. It's something very simple. You just have to read and do more exercises. You will get used to that. Now let's go to exercise number 2. The conversion or synthesis, the preparation. How can we transform one compound into another compound? So here we have an example. How can you convert 2-chloropropane into 2-methylpropane 1-ol? Remember, so this is 2-chloropropane, and here we have 2-methylpropane 1-ol. Remember, we said that to work out this question, it is always important to start by drawing the structure formula of the compounds, especially the one we want to produce, so that we can know the transformations we can carry out and get to that compound. So, without delaying, we have 2-chloropropane. Here it is the preparation. 2-chloropropane, it's this one, CH3, CH, Cl, and CH3, and we want to move from this one to CH3. It is 2-methylpropane 1-ol. So we have CH2, OH, and CH3. Now, what we are going to do is to analyze how the compound has been changed and see or think about the reactions which can help us to bring about those transformations. Here we have 2-chloropropane. Here we have chlorine. This is a branch. Let's consider it as a branch. And you can see that the part we have here, this part, is similar to this one. Okay? So I have the idea of, and here we have, it's like we have added an aldehyde. So think about taking the aldehyde and reacting it with a Grignard reagent. Here we have an alkyl halide. The alkyl halide which can easily be transformed into a Grignard reagent. And after getting the Grignard reagent, are we able to find an aldehyde? Methanol. If we use methanol, we can produce this compound. So let's find a way of producing the Grignard reagent and making that aldehyde, methanol. From this compound, the compound we have, the only organic compound we can use or start with, we can eliminate. You remember the reaction we called dehydrohalogenation. We remove HX molecule. So with that, it's an elimination reaction. With that, we can produce a double bond. And the oxidation of the double bond will give us what? The oxidation of the double bond, if we use weak oxidizing agent, we can produce aldehydes. And I'm very sure from the aldehydes we will produce, there will be methanol. Let's try it. We have CH3CH, chlorine, CH3. If we add sodium hydroxide and we reflux in the presence of ethanol, remember we use ethanol. If you use water, you will get a substitution reaction or a substitution product. So to have an elimination, because we want to create a double bond, we use ethanol. And we get CH3CH, CH2 plus sodium chloride and H2O. Now we have our double bond, the product with the double bond. And from this one, the product with the double bond, we can get an aldehyde. Which oxidizing agent do you remember that can be used to give us an aldehyde? Remember, when you oxidize double bonds and you use strong oxidizing agents, you produce carboxylic acids. If you want to produce aldehydes or ketones, depending on the structure of your alkene, you have to use, for example, ozone, the reaction we commonly call ozonolysis. So if we use ozone here, in the presence of water, what do we produce? We produce CH3CHO plus, because the bond will be broken at this level, and we get CH2O plus H2O2. Now we have our methanol molecule that can be used to introduce this part in the molecule we want to get. But to make this methanol react or get attached to this one, we have to transform the alkyl halide we have started with, this one, into a Grignard reagent. How do we transform alkyl halides into Grignard reagents? You just treat them with magnesium and you use ether as a solvent. And what do you get? CH3, CH3, and here we have magnesium chloride. Now we have the two reagents we need. If this one combines with this one, what do we get? Do you remember what we get from? Here there is an example, what we have used as the example in the previous exercise. So we have CH3, CH, let me write it like this, CH3, and here we have magnesium chloride reacting with CH2O, and what we get here is, if we treat this or we carry out this in the presence of water, we can immediately get CH3, CH3. This is the part from the Grignard reagent, and we add the aldehyde to get CH2OH. And remember, we have said that this hydrogen comes from water, and because of that, we produce ClMgOH. Now we have our alcohol. So if you have thought about it like this, then you were right. You can also try more exercises. Now let's go to the third exercise, and another type of exercises we can have in this organic chemistry unit number 6. An organic compound of molecular formula C3H8O was heated with acidified potassium manganate 7, and a compound B was formed. B didn't react with Torrens reagent, but gave a yellow precipitate with Brady's reagent. Identify compounds A and B and write all the equations for the reactions described. Let us go back and we read again. An organic compound of molecular formula, this one, was heated with acidified potassium manganate 7, and a compound B was formed. From the molecular formula we have there, we can identify what kind of compound it is, because we can start from the molecular formula and determine the general molecular formula. That you can see that is, this is exercise number 3, C3H8O. This is the same as Cn for a given number of carbon atoms. We have Cn, and then here we have H2n plus 2 and O. This is the molecular formula for alcohols. And there is another thing we can use. From here, we can see that they're saying it was heated with acidified potassium manganate 7. And this is an oxidizing agent, so it was oxidized. And a product B from the oxidation was produced. And here we are using the statement, B didn't react with Torrens reagent, but gave a yellow precipitate with Brady's reagent. Do you remember the type of substances or molecules, compounds, organic compounds which react with Brady's reagent? The carbonyl compounds only. Ketones and aldehydes. But here it is very specific. It is said that B didn't react with Torrens reagent. And remember, Torrens reagent reacts with aldehydes only. It doesn't react with ketones. So this shows that we started with an alcohol, this one, which was transformed by oxidation into a ketone. The ketone which could react with Brady's reagent, but which cannot react with Torrens reagent. And then we have this compound, CH3, and here we have OH. This is compound A, and the alcohol. And this one was oxidized by potassium dichromate in acidic medium to produce CH3COCH3. And this is the equation for the reaction of this oxidation. This compound also, they say, it reacted with Brady's reagent. If we add Brady's reagent, which looks like this, this is Brady's reagent, 2,1,2-NO3, 3,4,2,4-dinitrophenylhydrazine. What do we produce? We produce CH3, CCH3, and then here we have a double bond with the nitrogen and NH and our ring here. NO2 and NO2 plus H2O. This is the product we get. So we have the equations. Okay? Now we go to the next exercise. The next exercise, here we have 3 compounds, E, F, and G, all have the molecular formula C3H6O. E is an alcohol, F is a ketone, and G is an aldehyde. Draw all possible structure formula of E, F, and G. We have a molecular formula, that is question number 4. The structure, the molecular formula is C3H6O. This can represent aldehydes, a ketone, or an alkenol, an alcohol which contains a double bond. Now, they are saying E is an alcohol. So if it is an alcohol, then it is the alcohol which contains a double bond. F is a ketone. For the ketone, it's very simple, and the aldehyde. Why? Because the only ketone we can have which has 3 carbon atoms is this one. And that is F. And it is said G is an aldehyde. So some questions may be very easy. You read them and immediately you get the answer. And G, that is the aldehyde, it can only be CH3, CH2, and COH. Only this one. There is no other alternative. Now we have to draw the alcohol. So the alcohol will be this one, CH2, CH, and CH2OH. Why is it like this? Why can't we have the OH on this carbon or this carbon? It's because, if you remember, alkanols, when the OH is located on the carbon having a double bond, then the compound can exist in equilibrium with its tautomer form, which may be the aldehyde or the ketone. So to have an alcohol only, it should be this one. And this is E. Now, let's go to the chemical tests. Describe tests. You give the reagents and conditions and, of course, the observations that will allow you to show that E is an alcohol while other compounds are not. Remember, here we can use a reaction with a reactive metal, for example. Alcohols, for example, react with sodium. And the observation is the production of hydrogen gas. But the ketones do not. Okay? That is one of the tests you can use. Carbonyl compounds do not react with sodium, but the alcohol reacts. F and G are carbonyl compounds, whereas E is not. We know the substance we use to show that compounds are carbonyl compounds, while others are not. That is Brady's reagent. So we can use Brady's reagent, and we get a yellow-orange precipitate, while for the alcohol there will be no observation. To show if a substance is an aldehyde while others are not, we use Tholen's reagent to get a silver deposit. You can use Fehling solution to get a brick red precipitate. Those are possible chemical tests you can use. So this is very simple. And the question we have here, I want you to try it when you will get time. The carbonyl compounds, or carbonyl compound, it's one, there is no, this S is not there, undergoes the following reactions. I will read it and explain so you will get the answers. X gives an orange precipitate with 2,4-dinitrophenohydrazine. We remember the compounds which react with this substance. This is the Brady's reagent. So you can deduce something from this statement. X gives a pale yellow precipitate with a mixture of iodine and sodium hydroxide. We know the purpose of using this mixture in the chemical tests. And then X doesn't react with warm acidified potassium dichromate solution. We know the substances which cannot undergo oxidation. That is an oxidizing agent. X doesn't react with aqueous bromine. We know what it means. And then X is reduced by hydrogen in the presence of a catalyst to a compound Z of molecular formula. This is the molecular formula. You can reduce the class or the homologous series to which it belongs. And then it is asked, give the structure formula of X and Z. Analyzing all these statements and deducing the information behind each one, you will get the structures of this X and Z. Now let's go to the last, which is very simple, before I can read for you the other exercises. Propanol is a liquid at room temperature with a boiling point of 49 Celsius degrees. It is prepared from compound Z as follows. It is mixed with dilute sulfuric acid and potassium dichromate. This is an oxidation at this temperature to ensure that propanol vaporizes as fast as it is formed. Give the name or the structure of compound Z. So that must be an alcohol because we are oxidizing. And here what compound we are producing? Propanol. So it must come from the alcohol with three carbon atoms, that is propane 1-ol. Why is propanol distilled? To prevent further oxidation, of course. The color change, you can determine that. So you can try all these other questions. The reagent we can use to confirm the functional group, that is for the chemical test. And we give the product, the structure of the product when propanol reacts with hydrogen cyanide, the nucleophilic addition reaction. You remember that. So you will try the exercise. And here we have more exercises to try. Describe how you can distinguish, this is the chemical test, propanol and propane. Number 2, how can you distinguish propanol and ethanol? Very simple. Here we have the chemical tests. And number 2, P has the molecular formula C5H8O2. It reacts with hydrogen cyanide to form a compound of molecular formula C7H10O2N2. P gives a positive iodoform test, a silver mirror with Torrens reagent, and can be reduced to pentane. Draw the structure of P. You can see we have 2 oxygen atoms. So think about having 2 functional groups, carbonyl groups. So thank you very much. You will read all the information, you analyze it and deduce what is the meaning behind, and you will do the exercise. I thank you very much for your attention, for your participation, always being there. I hope to see you next time. Thank you.